And welcome back. I've already had so many great sessions before, and unfortunately, this is already the last session that we have on this stage today. We have our final use case, and I'm delighted to welcome Leonard Mabele, Manager, IoT Research Lab, and co-founder of Tungana, who will present on how decoding strategies affect the verifiability of generated text. And that's a very difficult word, but over to you, Leonard.
All right, thanks, Stephanie. I'm not sure that the topic you just mentioned is mine, but I'll cover what I have from my end. So I hope everyone can see my slide. Stephanie could confirm for me if everyone can see my slide, and then I can just proceed.
Yes, Leonard, we can all see you. Perfect. Please go ahead.
All right, thank you. Hello, everyone. It's almost 7 p.m. here in Kenya, and I hope everyone has had a very interesting session throughout the World AI Summit. Now, I'm just going to share some of the new research work happening over here. So a bit about me is, as Stephanie has introduced, I lead the Internet of Things research here, but I also couple up as a PhD research fellow in wireless communications. And the topic I'm going to is AI for dynamic spectrum access. So we have sort of have a new project here. We just dubbed more cognitive radios, and we are investigating models of AI on spectrum sharing, especially through the use of cognitive radios. As a background, currently there is the challenge of radio spectrum allocation, where we kind of feeling, and regulators are feeling, that spectrum allocated to licensees is not being optimized. So quite a number of challenges are coming out, just pointing out towards the inefficient utilization of the spectrum itself. And so I think way back in 2006, there was the Geo6 plan that led to the analog switch off. And quite a number of countries have been deploying TV white spaces, which is just a part of the spectrum that enables kind of secondary utilization of the TV band in provision of wireless internet access. So a number of countries have been leading this, of course, UK, US, Singapore, and a number of them, including South Africa and Ghana for Africa. And Kenya just finished its final studies for the framework, which will be released by December. Luckily, I was part of the project, and some of the lessons I picked up is what I'm going to present here, including extensions in terms of the work that we're beginning on AI. So dynamic spectrum access, I'm not sure how the audience is made up of, but it's basically a way of borrowing spectrum from the licensed services, which are not using some of those frequencies. So for example, in TV broadcasting, we have the TV broadcasters not fully using the frequencies allocated to them. So we come up with a way where regulators borrow that and make it available for other people to deploy other services that can just sort of address the problem of the digital divide. And that is what dynamic spectrum is all about. So some of the spectrum bands that are inspiring dynamic spectrum access, which in this case, again, in another language, would say just sharing spectrum, because it's borrowing from one and then kind of distributing around. So it's spectrum sharing. So some of the bands that are inspiring the whole journey of dynamic spectrum access, it's TV white spaces, which countries have done so much. 5G, there's work on FM radio bands, and there's work in the industrial, scientific, and medical bands. For 5G, I guess maybe Siemens must have mentioned in terms of their IoT work. So that's basically the initial deployments have been done on dynamic spectrum access. So some of the methods that the dynamic spectrum access is enabled is kind of fronting for usage notably there are three of them. So these three methods are used to just share the spectrum. So allow borrowing and shared distribution of the frequencies from the licensees to some secondary service providers. So the first one is geolocation database. The second one is spectrum sensing. The third one is beacon reception. Now, the first two are the more majorly used. The third method is never really mentioned a lot. But in terms of deployment or experience from here in Kenya, we have actually gone ahead and implemented the geolocation database technique in the draft. And I guess this is the method that UK is using, US is using, and quite a number of regulators. So some of the images I put over there is just on the left is the image that the model that the UK has adopted to utilize a TV white space. And then on the right, those are just quite a number of channels that we kind of found out in our project with our regulator here. So this brings me the second technique, apart from the geolocation database, which is not widely used as compared to the former one, and it's called spectrum sensing. So a lot of work has been done on this, and work has been done for almost 3 decades now. And this, very few regulators have really adopted its usage. I think globally, based on studies, we've only seen the US regulator, which is the Federal Communications Commission, try to implement that for TV white spaces, but not any other. So it's become an area of interest for us a lot more, even for the work that's happening in our country. There's currently no implementation on cognitive radio yet. So that brings us to more studies into it from our perspective. And we have been looking at how do we build more studies on it. Now, a lot of content on this slide is all over the internet. It's basically in some of the best books written by some of the founders or people who build the foundation knowledge on software-defined radio. Of course, to be specific, is the guy, Joseph Mitola 3, did some of is the guy who came up with the software-defined radio work and cognitive radio terms. And for those who do not understand, a cognitive radio in this case, just plugging into what spectrum sensing would be, is just a way of having a really smart radio that is self-aware, it's radio frequency aware, and has some language technology that comes with high fidelity of knowledge of the surrounding electromagnetic environment. So what is extending cognitive radio work is just having some new radios that ensure that the baseband processing happens in small chipsets as opposed to the big hardwares. In this case, just cutting the cost of the hardware and pulling all of that into software development. And with me here, I have one of the software-defined radios that we've been working with. Of course, some of people who've been working on AI for hardwares on software-defined radio. This is an RT and SDR. And extending our work here on AI is us trying to deploy software algorithms on these radios, just trying to understand the frequencies available and making the kind of a custom implementation of cognitive radio implementation for Kenya now. So some of those images are just some of the work that we have here. So thereabout, we have some Lime radio that we've been using for quite a number of things. And then we have quite a number of other open source software-defined radios that we've been using to deploy some of the AI potential algorithms that we are building over here. And how does AI apply into this? So it's just the concept of using machine learning, applying to the cognitive radios themselves and maximize the ability of DSA. DSA, of course, I've mentioned earlier on, is just sharing the spectrum. So the biggest challenge of all this is, the biggest challenge of dynamic spectrum access is interference. That's why the cognitive radio aspect has to be examined a bit differently. So that means even as we say the TV white spaces are being utilized to provide internet access, how is the operation of them in relative to the primary services that run in that band? So in this case, the TV broadcasting. So the interference being the biggest problem, that it's kind of the driver that has led to the methods of spectrum utilization being examined from that perspective. And in this case, looking at spectrum spectrum usage through cognitive radios. So what we're doing with here in terms of AI, we kind of have a model where we're just having a knowledge base of things. So we kind of maintain a system that has a state of the available parameters of them that can be used as model inputs into our algorithms. So in this case, you're talking about the available frequency, available quality of the channels themselves, the errors that come with transmission, errors in the frames. So those comes the model inputs that we are applying in our machine learning algorithms for the AI in DSA. And then our outputs, you're looking at the end of the day, can we be able to intelligently, based on location, extract what will be the available channels, what will be the available operating parameters for the secondary services in terms of power, in terms of antenna height, spectrum mask. So those are some of the things that we've been looking at, and some of the learning algorithms we are really been focusing on is hidden Markov model and retropropagation algorithms. So these are kind of known algorithms, but we're just trying to tweak them into a new, a better approach of implementing radios to have a more cognitive demonstration of dynamic spectrum access. So looking at apart from the knowledge base, keeping all these, maintaining this state, we kind of interface it with the reasoning engine. And of course, the engine is basically making giving us choosing the best action based on the knowledge, and then based on the state provided by the knowledge base. And then the continuous algorithm building up a more iterative machine learning model is another piece called the learning engine, which is kind of just below the reasoning engine and the slide I have right now. And that is sort of just realizing the manipulation of the knowledge base based on the outputs provided by the reasoning engine, and iteratively creating a way of understanding the information that can specifically or precisely be in use for the radios. And all of these on the left, as you see, you have a software-defined radio there. So all the software algorithm being built within the AI capabilities applied on the hardware of the software-defined radio. And that's what we're trying to work out to be able to implement a DSA-driven cognitive radio as opposed to the geolocation database approach. So in terms of that's the end of my presentation. I really didn't have much to share with you, but I just wanted to give you an overview of a very interesting project we are beginning to work on based on AI for dynamic spectrum access, focusing on spectrum sensing as opposed to the geolocation databases. Thank you, Stephanie. So if anyone has any questions, feel free to reach out. It's a big research you're working on in collaboration with the Communications Authority of Kenya, who is our national regulatory authority, and a number of research partners in the UK and other African countries here.
And thank you so much, Leonard. This was truly insightful. My knowledge of dynamic spectrum access was very limited coming into this, but I loved listening to your work on cognitive radios to find white spaces. So thank you so much for educating us all. And yeah, if you have any questions for Leonard, please follow him into the Lounge Networking /speaker Q&A room. The link to that room will, of course, be shared with you right now in chat session. So you can follow him there. He can turn his camera on and you can ask any questions that you like regarding this. And that will conclude our sessions on the main stage today. But starting now in the session stage, we have a focus session on space education and youth participation, where our illustrious panel of experts will be looking at what kind of young children can be active in the space sector. Over there now, if this is of interest to you. And for me, it has been a hugely informative day, and I'm sure for you, the viewers, as well. And so I want to give a massive thank you to all our speakers. And we look forward to seeing you all again at the next Inspired AI session at the earlier time of 11:15 Central European Time. That is on Wednesday, on the 14th of October. And there we will be focusing on getting the future right with our biggest speaker roster to date. So please make sure you subscribe to that one. And for everyone viewing still right now, you can head over to the sessions area on the platform. And you will also find there that the networking lounge is open. You can use the chat on the right-hand side to start a conversation, or click the participate button to share your audio and camera to go live on screen. We can have up to 9 people live at the screen at any one point in time, so be quick. And if you want to start a topic of your own, you will also be able to create your own subgroups. Simply click on the +@session button in the top right corner. Complete the details and your session will appear automatically. And so you can invite people to join by posting in the networking lounge or in the event chat. So feel free to start creating groups on the topic, industry, geography, whatever you want. And be sure to the Tech Talks WhatsApp group to continue networking post-event. So simply head over now to the sessions area, scan the QR barcode or enter the lounge and click on the link to join. And thank you so much for being here today. And I look very much forward to seeing you again soon. Thank you.